Hello everyone, welcome back to Math Verse by Vishal. So in the previous videos, I have already discussed the top 10 PYQs from both 2nd and also 4th April JEE mains, right? Now in this video, I'm going to discuss the top 10 questions you should not skip before going to your JEE Advanced and also next sessions of JEE mains. And these are the questions from 5th April morning shift. Okay, so let us try to see the questions one by one here. So let us see the first question for today. This is a question from definite integration and it is one of the standard question actually. So we have different methods to solve this question, but I'll tell you the easier one for this. So let's take the given question as some capital I. Let's say capital I is equals to integral 0 to infinity. This is ln of x divided by x square plus 4 of dx. Okay. Now the main idea you have to get here is putting x is equals to 4 divided by t. Okay, it's a standard idea. You can take this as a trick whenever we have integral 0 to infinity ln of x dx divided by some x square plus constant k here. What you need to do is you need to put x is equals to k divided by t and you try to proceed. Okay, you will understand what's the reason behind that. So let's try to change the variable. If you put x is equal to 4 by t, I can say that dx will be is equals to minus 4 by t square of dt. So the question changes to I is equals to integral. Now the limits also will be changed obviously, right? Because if you put if you put x is equals to 0, you get this will be infinity. And then if you put infinity, you get 0. So limits will be interchanged. And this will be ln of 4 divided by t and dx value is minus 4 by t square dt whole divided by x is 4 by t, right? So this will be 16 by t square plus 4. Okay. Now let us try to simplify this expression here. So capital I will be is equals to integral infinity to 0. I'm going to write this ln of 4 by t as ln 4 minus of ln t. Okay. And this is minus of 4 divided by t square and whole divided by, in the denominator part, you can take 4 common. And after taking 4 common, after taking LCM, you get this as t square plus 4 whole divided by t square. Clearly, this 4 gets cancelled and also t square gets cancelled. And I'm going to interchange the limits because I have an extra minus 1, right? Since I have an extra minus 1, I'm going to interchange the limits as 0 to infinity back. And I'm going to write this as ln 4 minus ln t of dt whole divided by t square plus 4. Okay, so this is a huge advantage here because if you take this as equation number 1, the given question itself as some equation number 1, and let's take this as equation number 2 here. Equation number 2. Try to add both of them. Okay, try to add both of them, or else you can split this integration also. Never, anything is fine actually. If you write this as integral 0 to infinity, this will be ln 4 divided by t square plus 4 minus of integral 0 to infinity. This is second term is after splitting ln t divided by t square plus 4 of dt. But as you can see here from the equation number 1, this integral 0 to infinity ln t divided by t square plus 4 is nothing but capital I again. So this is capital I. So that if you take that I to the left hand side, that becomes 2i. 2i is equals to ln 4 is a constant, ln 4 in integral 0 to infinity t square divided by t square plus 4. Now it is a direct formula known to us, 1 by a tan inverse of x by a, right? So I will be is equals to ln 4 divided by 2 multiplied by 1 by a is 1 by 2 multiplied by tan inverse of x by a, that is tan inverse of t divided by 2. And you can put the limits here 0 to infinity. So if you put infinity here, you're going to get this as ln 4 by 4 multiplied by tan inverse of infinity will be pi by 2 and minus of this will be what if you put t is equal to 0, this will be 0. So finally what we get is I is equals to capital I is equals to pi into ln 4 divided by 8. So this is your required value. Okay. So as I told, this is a trick for this question. Whenever we have integral 0 to infinity ln of x dx divided by x square plus k, you try to go for the substitution x is equal to k by t, so that you will get the answer in very few steps. It won't take much time to solve these kind of questions. Okay. Let's take the next question. And this is a question completely based on solving functional equations using partial derivatives. In one of the previous videos also, I have done a question based on this partial differentiation process. If you have not seen that, go through it once again. It is almost a similar question. So let's use partial differentiation. I'll write that. Partial differentiation with respect to x. Okay. So if you differentiate partially with respect to x, this is going to be f dash of x plus y by 3 multiplied by 1 by 3 is equals to, this is 1 by 3 times of f dash of x, and then plus 0 anyhow, because f of y is a constant when you are differentiating partially with respect to y, with respect to x. Now I'm going to put x is equals to 0 in this one. If you put x is equal to 0, this becomes f dash of y by 3 is equals to f dash of 0, and f dash of 0 is already given as 3 in this question already. So you get f dash of y by 3 is equal to 3, and you put again y with some 3x. Okay. If you replace y with 3x, you're going to get this as f dash of x is equal to 3. Now you know f dash of x is equal to 3. So f of x on integrating will give you 3x plus some constant k. Okay. But you still need one more condition to get the value of k here. For that, what I can do is you just simply put x is equal to y is equal to 0 in the given equation itself. From there, you get f of 0 is equals to f of 0 plus f of 0 whole divided by 3, which gives you 3 times of f of 0 is equals to 2 times of f of 0. That is, f of 0 must be is equal to 0. So since you got f of 0 is equal to 0, take that and substitute it back, from which you get k is equals to 0. So if k is equal to 0, finally your function is f of x is equal to 3x. Okay. So now since you got f of x is equal to 3x, but the question is not over yet, because there is one more function defined here. Let's see that. So g of x is given as 3 plus e power x into f of x. F of x is nothing but 3x here. Now you have to find out the minimum value of the function g of x here. To find out the minimum value of a function, what is the process we know? Obviously differentiation, right? So first of all, let me take 3 common here, or let's differentiate directly, no problem. G dash of x is equal to 3 is a constant, so 3 times of, now e power x into x differentiation, which is e power x into 1 plus x into e to the power of x. Now, if I can take this e power x also common here, so this becomes 3 into e power x multiplied by x plus 1. Now, once again, if you want to find out the maximum or minimum, the first thing you need to equate it to 0 and find the critical points, right? Because it is a clear differentiable function. The only possibility is the derivative is equals to 0. So make it to equal to 0. You get x plus 1 is equal to 0, which means x is equals to minus 1 is a critical point, right? And also we know that definitely this is going to be the minimum point of minimum, because you can check for the first derivative test. G dash of minus 1 minus is going to be a negative value, and g dash of minus 1 plus is going to be a positive value. So clearly at minus 1, the sign changes from negative to positive, which means x is equal to minus 1 is the point of minimum. So that is why if you want the global minimum of this one, take this x is equal to minus 1, and minimum value is going to be g of minus 1. So let's calculate g of minus 1 here. So g of minus 1 is equals to finally 3 plus e power minus 1 multiplied by 3 into minus 1, which will give you finally 3 minus 3 divided by e. Or also you can take LCM and write the answer as 3 times e minus 1 divided by e. So this is how you have to do this question. And also I'm once again reminding you, I've already made a video in which I discuss this question, a similar question based on of similar question to this. Okay. So try to go through it once again if you are not clear with that, right? Let's take the next question. This is a question from inverse trigonometric functions, and this is one of the most repeated PYQ questions from inverse trigonometric series using tan inverse functions. Okay, so let's see the process once again. We need to concentrate on this one, tan inverse function first, because our ultimate aim is to convert this into the form of tan inverse of x minus y divided by 1 plus xy. So that we can split this form as well, tan inverse of x minus of tan inverse of y. So for that, what I'm going to do is, first of all, I'll try to simplify this tan inverse function, then I'll substitute the sigma. So tan inverse of this becomes 2 to the power of p minus 1 divided by 1 plus. I can write this 2 to the power of 2p minus 1 as 2 to the power of p multiplied by 2 to the power of p minus 1. Right? And the main advantage is this numerator part 2 to the power of p minus 1 is nothing but 2 power p minus of 2 to the power of p minus 1, because if you take 2 power p minus 1 common on the right hand side, again you will get 2 power p minus 1 is equal to 2 power p minus 1. So that's the basic idea here. Writing the numerator 2 power p minus 1 as 2 power p minus of 2 power p minus 1. So that finally what we have is tan inverse of 2 power p minus 2 power p minus 1 divided by 1 plus 2 power p into 2 to the power of p minus 1. So let us take this simplification part and substitute back in the sigma. And moreover, let's write one more step also directly, because this is exactly in the form of tan inverse of x minus y divided by 1 plus xy, which will give you tan inverse of x minus of tan inverse of y. Right? So let's take this value and substitute back in the question, and let's see what we'll get. Alpha is equals to, it will be pi divided by 4 plus sigma p is equals to 1 to 11. This is nothing but tan inverse of 2 to the power of p minus of tan inverse of 2 to the power of t minus 1. Now it is a simple concept of what? Telescopic summation here. If I take this as some Vp here, this is going to be Vp minus 1. And now the question changes to directly alpha is equals to pi by 4 plus sigma. P is equals to 1 to 11 Vp minus of Vp minus 1. And if you expand, I think you know how to do this telescopic summation, right? If you expand, what you're going to get V1 minus V0 plus, if you put P is equal to 2, you get V2 minus V1. And then so on up to last term, it is going to be V11 minus V10. So clearly all the terms will be cancelled out except two terms, that is V11 minus V0. So finally we get alpha is equals to pi by 4 plus V11 minus of V0. Okay. But we have already taken Vp as tan inverse of 2 to the power of p minus 1. So we know how to find out V11. So pi by 4 plus V11 is nothing but tan inverse of 2 to the power of 11 minus of, this is tan inverse of V0. V0 means putting p is equal to 0. So 2 to the power of 0. So tan inverse of 2 power 0 is what? Tan inverse of 1. Tan inverse of 1 is pi by 4. So plus pi by 4 minus pi by 4 gets cancelled. And finally we get alpha is equals to tan inverse of 2 to the power of 11. But we have to find out tan alpha. So if this is alpha, then obviously we get tan alpha is equals to 2 to the power of 11. So it's a very simple question, but one of the standard questions and one of the most repeated questions from inverse trigonometric functions in JEE mains. Let's take the next question. And this is a question from limits. And the question is based on direct expansions of cos and sine functions. Let's see how we can do this one. First of all, let us try to recall the expansions of sin x and cos x. And sin x expansion not required here, only cos x is required. I'll tell you what's the reason behind it. Cos x expansion is what? 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on. Right? So here, first of all, in the denominator, we have sine of alpha plus 1 x whole square. So which means I'm going to multiply and divide by alpha plus 1 whole square into x square. Okay. I'm going to multiply and divide by alpha plus 1 whole square into x square, so that as x tends to 0, this term will be anyhow is equals to 1. Okay. So the question gets reduced here somewhat. And then if you observe carefully, if I want to expand this cos of alpha x here, okay, cos of alpha x expansion directly replacing x with alpha x in the expansion formula, which will give you 1 minus alpha x whole square, that is alpha square x square. Let's write down directly 1 minus alpha square x square divided by 2 factorial. I'm neglecting this higher powers of x because, as you can see, the denominator is containing only x squared terms, right? Higher degree terms are not required. So let us try to do that. Limit extends to 0. This will be 1 minus of. So as I've written here already, cos of alpha x is 1 minus alpha square x square by 2 factorial multiplied by, in the similar way, cos of alpha plus 1 x expansion can also be written in this way here, which will be obviously 1 minus of alpha plus 1 whole square into x square divided by 2 factorial multiplied by 1 minus of, similarly, this is going to be alpha plus 2 whole square x square divided by 2 factorial, and whole divided by, we have this as alpha plus 1 whole square multiplied by x square. Okay. So you just need to check what are the constant terms and x squared terms, obviously, because after x squared term, all the higher degree terms can be completely ignored because the denominator has x squared term as the only term, right? So let us try to write down only the constant terms and x squared terms. So limit extends to 0, 1 minus of. So if you want to get a constant term here, you need to multiply this 1, 1, 1, which will give you exactly 1, right? And then if you want the x squared term, one combination is this. One combination is this. Alpha square x square in by 2 factorial into 1 into 1. Okay, I'm not expanding completely. I'm just trying to collect the coefficient of x square from here. Okay. So the one possibility will be minus alpha square x square by 2 factorial. And as similarly, you can notice I can multiply this term with this one and with this one to get one more x squared term. So which will give you minus of alpha plus 1 whole square into x square by 2 factorial. Similarly, one more term will be minus of alpha plus 2 whole square x square divided by 2 factorial, and whole divided by alpha plus 1 whole square into x square. The main advantage is plus 1 minus 1 gets cancelled, and also after cancelling out 1, throughout x square also can be cancelled out in the both numerator and denominator. And if you look at the remaining part, this is only limit extends to 0. Minus of minus becomes plus alpha square by 2 factorial plus alpha plus 1 whole square by 2 factorial plus alpha plus 2 whole square by 2 factorial, and whole divided by alpha plus 1 whole square. And moreover, this limit value is given as 2 here. Okay. Now, shall we remove this limit directly because this is completely a constant term, right? So let's expand and see what you're going to get and cross multiply. Alpha square plus alpha plus 1 whole square plus alpha plus 2 whole square will be is equals to 2 into alpha plus 1 whole square. Moreover, you're going to cross multiply 2 factorial, you'll get one more 2 on the right hand side. The left hand side, if you expand, totally 3 alpha square plus 2 alpha plus 4 alpha, which gives us 6 alpha plus 4 plus 1, which is 5. And this will be 4 alpha square and plus 4 to 8 alpha and plus 4. If you simplify, finally what we get is alpha square plus 2 alpha and minus 1 is equals to 0. Alpha square plus 2 alpha minus 1 is equal to 0. So let's look at what's the required part here. We have to find out the product of all possible values of alpha, right? So directly we don't need to find out the roots, right? Because we just need the product of values here. Simply apply product of the roots. Alpha 1 into alpha 2 is equals to c by a, which is minus 1. So directly it should be the option 2 here. Okay. So some students might go for L'Hopital rule for this question. You can do that also. But I personally feel this expansion is going to give you a proper method and without any errors. Okay, and it will take some less amount of time also while solving limits based questions. Okay, I hope it is clear. Let's take the next question, and this is a question from areas, and once again it's a pure replica of one of the previous advanced questions from areas chapter. Okay, it was one of the previous advanced question. They have simply changed some numericals here and it is almost the same question. Okay, so let's try to see how to do this question. So we have basically two inequalities. The first one is x into y less than or equals to 27, which is clearly a hyperbola. And the second one is y greater than or equals to 1 and also less than or equals to x square. So just to give you more clarity, I'll draw both the graphs and then I'll combine both of them and I'll draw in a single diagram. Okay, first let us draw separately so that you'll get more clarity. So x into y is equals to some constant is always what? A rectangular hyperbola, standard case. Okay, so this is your hyperbola. And since you have x into y less than or equals to 27, it must be the region between the two branches here like this. Okay, it must be the region between the two branches, right? And then the second inequality, let's draw the second inequality also. We have double inequality, which is y less than or equals to x square. First of all, this is y is equal to x square. This is y is equal to x square. And since it is y less than or equals to x square, it should be the region below the parabola y is equal to x square. And then y is greater than or equals to 1. So this is y is equal to 1 straight line. So which means the required region is above the straight line and also below the parabola because it is y less than or equal to x square. So if you take that common region to both of them, that is above the line and below the parabola, this is how the region looks. Okay. Now let's try to combine both of them and try to plot both of them in a single graph. But before doing directly, let's try to find out the points of intersection. And only after that we can draw a proper diagram. The first thing here, let me solve this y is equal to 1 and y is equal to x square first. So if you solve these two, you get x square is equal to 1, x is equals to plus or minus 1. So which means this point here would be 1 comma 1. This is minus 1 comma 1. Okay. And let us try to solve this x into y is equals to 27 with the straight line y is equal to 1 first. So if you try to solve a hyperbola and the straight line, obviously you get x is equal to 27. So which means the point of intersection of hyperbola and the straight line will be 27 comma 1. And then let's try to solve this x into y is equals to 27 with the parabola y is equal to x square. We need all the points of intersection because we don't know the exact position. We can't tell the exact position without finding out the points of intersection. Okay. So let's put that here y is equal to x square, which gives you x cube is equals to 27, which gives you x is equal to 3. So if x is equal to 3, y will be is equals to 9. So which means the point of intersection is 3 comma 9. Now you have all the points of intersections here. Look at this. 27 comma 1 is one point of intersection, 3 comma 9, and also 1 comma 1 and minus 1 comma 1. Now let's try to put everything in one single graph and then we'll start the question. Because once we understand how the graph is, then the remaining part is only integration, right, to find out the area. So this is the first region branch of the hyperbola, which is y is equals to 27 divided by x. Okay? And then let me draw the parabola here. This is the parabola. Y is equal to x square. But just now we have solved this parabola and also hyperbola, right? What was the point of intersection? 3 comma 9. So this point here is 3 and this point here is 9, 3 comma 9. And then since this is 9, y is equal to 1 will be definitely below this point 9. So this is your straight line, y is equals to 1. Okay. Now let's try to understand one thing very clearly, and we have the other branch also obviously here. But if you take the common part for everything, that is, the region should be between the two branches of the hyperbola and also this green color shaded part, as you can see in the right side diagram there. So if you observe carefully, it should be between the two branches of the hyperbola and below the parabola and also above the straight line. Now, as you can see, there is only one common region for all these, and this is that. Okay. This is the common region that we are talking about. So to find out this region, obviously you have to split the cases, right? Because this is the point x is equal to 1 here. And this is a point x is equals to 27 because already we have solved for point of intersection, right? 27 comma 1. So from 1 to 3, because I'm going to split this into two cases. This is one part and the next one is the second part. So to find out the area, the first part, this area here is given by integral 1 to 3. And in this case, what is the upper curve? It is a parabola x square minus of lower curve is the straight line y is equal to 1. So x square minus 1 dx. Now, what about the second region here? This region, the right side one, and that is from 3 to 27, right? So integral 3 to 27. And in this case, the upper curve is hyperbola, which is 27 by x. Minus of lower curve is once again the straight line, minus 1 of dx. Now you know what to do. You just integrate it and properly substitute the limits to get the final answer. Okay. So drawing the graph is the most important part because the area solving is very easy in this question. Okay. So try to go through it once again. As I already mentioned, this is a pure replica of one of the previous JEE advanced from areas chapter. Okay, let's take the next question. And this is a question based on trigonometric equations. So the question is find out the sum of integral values of p for which the equation 3 sine square x minus 12 cos x minus 3 is equal to p has at least one 0, which means this equation should have at least one solution. And if that is the case, we need to find out how many possible values of p are there, and moreover, we need to calculate some of the integral values of p. And once again, this is a similar model to the question which we already discussed in the one of the previous videos, that is which was made on the PYQ sessions. Okay, so once again, you try to go through that. So what was the idea that we have already discussed here? The thing is, you need to find out the range of the left-hand side part and then make sure the right-hand side constant p also lies in the same range, right? So this was the idea which we already discussed. So let's take the left-hand side as some function f of x here. F of x is equal to 3 times of, and I'm going to write directly here, sine square x is 1 minus of cos square x minus 12 into cos x minus 3. So clearly plus 3 minus 3 gets cancelled. The remaining part is f of x is equal to minus 3 cos square x and minus 12 cos x. Okay. Now the idea is to find out the range of this function, right? To find out the range of this function, you can use different process actually. You can use differentiation or also you can go for perfect square method also. So let's take the differentiation process. For example, I can take this as some y is equals to minus 3t square minus of 12t, where I'm taking t is equals to plus x, but I have to keep in mind that t only belongs minus 1 to 1. Okay, because cos x range is minus 1 to 1, right? Now, if I want to find out the critical points of this, obviously I have to differentiate this and equate it to 0. So dy by dt will be is equals to minus 6 into t minus of 12, equate it to 0. 6t is equals to minus 12, which makes t is equals to minus 2. But t is equal to minus 2 is not possible because what is our range of t here? Minus 1 to 1. So since we don't have any critical point in that t belongs to minus 1 to 1, obviously to find out the maximum and minimum of the function, you need to evaluate the extreme values, right? So let's try to find out value of y at a t is equal to 1 because you're using the concept of what? Global maxima, global minima, right? After finding critical point, the next step is to find out the values of the function at extreme values here. This is why y value at t is equal to 1 will be minus 3 into 1 square, which is 1, minus of 12 into 1. So which means you get y at a t is equal to 1, which is equals to minus 15. And similarly, let's calculate the y value at a t is equals to minus 1, which will be is equals to minus 3 times of minus 1 whole square minus 12 into minus 1, which will give you minus 3 plus 12, which is equals to 9. So finally, you got both the extreme values also, which is equals to 9 and also minus 15. Okay. Now here, what is our concept of global maxima, global minima? Whatever values we have got, that is minus 15 and 9. Out of these, the maximum value is 9. So which makes f maximum, the maximum value of the function is equal to 9. and the minimum out of these two is 15, which means f has a minimum value minus 15. Okay, so that is the left hand side LHS belongs to minus 15 to 9, that is minimum to maximum closed interval. Now, as I told earlier, right, if the left hand side is lying in between some interval minus 15 to 9 as per this solution, this right hand side also must be lying in the same interval. So this implies P also lies in the interval minus 15 to 9 closed. Okay. Now, in this interval, what we are supposed to find out? Let's see the question. We have to find out sum of all the integral values of P. Okay. So you have the interval with you. You count how many integers are there in this, and then add everything to find out the final answer. Okay. I hope it is clear. Let us take the next question, and this is one of the interesting question based on permutations and combinations. So let's try to see the question first. A and B play a badminton series, and the first one to get 5 wins is the winner of the series. Okay? The number of ways in which the series can be played if A is the winner of the tournament. So which means out of A and B, A has to win the tournament. And what is the winning case scenario here? The first one who gets 5 wins totally, he will be the winner of the game. So the main thing you have to understand from the question is you don't know exactly how many games are being played. That's the problem here. So that is why you must take all the possible cases here. So the case one is obviously uh, they play 5 games. Case one is totally they play 5 games and directly the person A is winning. This is one of the possibility obviously. So in the first 5 games that they are playing, every game is being won by the person A. So this is one possibility, obviously. So this is only one way of arranging it because everything should be won by the player A. So this is only one way here. Okay. Now let's take the case two. Now starting from case two, it is going to be interesting. So in case two, we'll take 6 games are being played. Okay. I hope you understand why we are not taking 4 games, right? Because in total, if 4 games are there, no person can win. Because if a person has to win, he has to win totally 5 games. Right? That's why I'm starting from 5. Now let's take the 6 games here. 3, 4, 5, 6. Now, if the person A is winning after the 6 games in the series, which means in the last game he has to win, obviously, right? Because at the end of sixth game, person A is winning. That's the second case here. So that is why the last game should be won by the person A. And in total, if person A is winning, he has to win 5 games, which means out of the remaining 5 games, 4 games must be won by the person A, and only one game must be won by the person B. I hope it is clear. So once again, case 2 is the case where at the end of sixth game, the tournament is over and the person A is winning, which means the person A is winning the sixth game, that is the last game. So totally how many games are remaining? Previously, 5 games are remaining. So in total, if the person A has to get 5 wins to win the series here, in the remaining 5 games, 4 games must be played by the person A and one game must be won by the person B. But here the order can be anything, right? Obviously, totally 5 places are there, and out of that, four places should be filled by A and one place should be filled by B. So which is nothing but 5 factorial divided by 4 factorial into 1 factorial, which is nothing but actually 5C1, right? And similarly, let's take the case 2 here. Sorry, case 3. Case 3 is at the end of seventh game, person A won the series. Okay, so let's try to understand here. At the end of seventh game, the series is over and the person A wins the series. Now, which means again, the last game must be won by the person A. So, if the last game is won by the person A, which means in the remaining 6 previous games, person A has to win 4 games, and totally 6 games are remaining, right? Previously, so out of that, if 4 games are won by A, remaining 2 must be won by B. So, which is nothing but arrangement 6 factorial divided by 4 factorial into 2 factorial, which is obviously 6C. This is case number 3. Let's take the case 4 here. Okay, I hope you're getting the pattern. Case 4 is eighth game. 4, 5, 6, 7, 8. So eighth game is won by the person A. So which means in the remaining 7 games, 4 games must be won by the person A and 3 games must be won by the person B here. And once again, what is the arrangement here? 7 factorial divided by 4 factorial into 3 factorial. That is simply 7C3. And next case is also possible, obviously. Case 5. What's the case 5 here? At the end of ninth game. At the end of ninth game. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at the end of ninth game, the person A wins the series. So which means again last place should be filled by person A. And in the remaining 8 places, four in four remaining 8 games, 4 games must be won by A, which leaves 4 games won by the person B. Right. Now once again, what is the arrangement of this one? 8 factorial divided by 4 factorial into 4 factorial, which gives you 8C4. Okay. But this is the last case. And what's the reason for that? Because if you take the next case here, that is at the end of 10th game, if the person A is winning, think what happens here. So if this is the 10th game and if the person A is winning at the end of 10th game, so which means the remaining 9 games, in the remaining 9 previous games, 4 games must be won by the person A. But if in the remaining 9, if 4 are won by A, remaining are 5 which are definitely won by B. And what is the problem with this 10th case here? If B is winning 5 games in the remaining previous 9 games, obviously the person B is winning here, not the person A, because whoever wins the first 5 games, he is the winner of the series. That is why this game ending at the 10th game won by the person A is not possible here. So only these cases are possible. You can add up all these cases, which will give you 1 plus 5C1 plus 6C2 plus 7C3 plus 8C4. So this should be your answer. Let's take the next question. And this is a question from differential equations. So look at the differential equation given to us here. It is x into sine of y by x multiplied by dy is equals to y into sine of y by x minus x multiplied by dx. Okay. Now, just by looking at the question, you might have got the idea that is it is a purely homogeneous differential equation, because if you try to rearrange the terms here, if you try to divide throughout by x into dx, let's see what you get. Divide throughout by x into dx, which will give you sine of y by x multiplied by dy by dx is equals to, this will be y by x into sine of y by x minus 1 after dividing throughout by x into dx. Now, very clearly you have everything in terms of y by x here. The idea is to put y is equals to x into t. That is y by x is equal to t. Now you know what to do. It's a homogeneous differential equation. This will be dy by dx is equals to x into dt by dx plus t into 1. Now we know what to do here. Let's substitute that here. So which will give you sine of t multiplied by, this is dy by dx, right? So what is dy by dx? X into dt by dx plus t. And that is equals to y by x is t multiplied by sine t minus of 1. So if you completely expand, let's see what we are getting here. This will be sine t into x into dt by dx plus t into sine t is equals to t into sine t minus 1. So advantage is this is getting cancelled. Now you can directly separate the variables here, right? I can write this as a sine t into dt, and I can send that dx and x to the right side, which will give us minus of dx divided by x. Now we know what to do. Directly integrate on both sides here. So integration of sine t will be minus cos t. This is minus cos t is equals to minus of dx divided by x, which is nothing but ln of x plus some constant c. But what is actually t here? T is nothing but y by x as per our solution. So this is minus of cos of y by x is equals to minus ln x plus c. So this is your general solution. But to find out the constancy, obviously they have given you the condition that y of 1 is equals to pi by 2, right? So which means y value is pi by 2 and x value is 1. So this will be cos of pi by 2 is equals to minus of ln1 plus c. So cos of pi by 2 is 0, ln1 is also 0, which will give you c is equals to 0. If you put that back here, c is equal to 0 in the general solution. Minus gets cancelled on both sides, and what we get is cos of y by x is equals to ln of x. So this is the particular solution of this differential equation. And the question is not over yet. So we need to find out the value of alpha, right? What's the alpha value given here? Cos of y of e power 12 whole divided by e to the power of 12. Okay. And then now you know what to do. That in this particular solution, you simply put x is equals to e to the power of 12, because when x is equal to e power 12, we can find out this value, right? So this will be, if you put x is equal to e power 12, cos of y of e power 12 divided by e to the power of 12 is equals to ln of e to the power of 12, because this is y of x. Y is a function in terms of x, right? It's like y of x here. Okay, I hope it is clear. This y here is like y of x function because it is a function in terms of x. Now that is why after putting x is equal to e power 12, we get cos of y of e power 12 divided by e power 12 is equal to ln of e power 12. But this is nothing but 12 on the right hand side because it is ln of e power 12. So finally we get alpha is equals to 12. Now, now let's take this value of alpha is equal to 6 and put it in the given circle equation. Because the question is given like this, the radius of circle is less than or equals to 6. So first the circle equation is given as x square plus y square minus 2px plus 2py plus alpha plus 2 is equals to 0. You can take this alpha and substitute it here, and we get x square plus y square minus 2px plus 2py plus 14 is equals to 0, given that r is less than or equals to 6 here. But we know how to find out r value here. R is square root of p square plus p square minus of 14. Okay, so which will give you square root of 2p square minus of 14. Right. And then given that this r is less than or equals to 6 here, but first of all, let's try to make sure this 2p square minus 14 is greater than or equals to 0. 2p square minus 14 greater than or equals to 0 will give you p square greater than or equal to 7. Let's keep it as one condition. And then if r is less than or equals to 6, we need to make sure square root of 2p square minus 14 is less than or equal to 6. Square on both sides. 2p square minus 14 less than or equals to, this is 6, right? So less than or equals to 6 square is 36. So finally 2p square is less than or equals to 50. That is p square is less than or equals to 25. Okay. So which means p square should be greater than or equal to 7, and also p square should be less than or equals to 25 to make it as a real circle. And finally we get p square belongs to 7 to 25. Okay. So from here you know how to find out how many integral values of p will satisfy. Just by looking at this interval also we can tell that p is equal to 0, 1, 2 will not satisfy. But starting from p is equal to plus or minus 3 will definitely satisfy. So plus or minus 3, plus or minus 4, plus or minus 5 will obviously satisfy here. So based on the, once we get the value of alpha, the remaining part is a simple circles based question here. Okay, you have to be careful. Let us take the next question here. Now once again, this is a question from definite integration. It is integral pi by 6 to pi by 3, 4 minus of cosecant square x divided by cos to the power of 4x dx. Now this question can be done in different ways, but I think the better one would be splitting the terms and solving them separately here. So let's look at the idea. What we are going to do is capital I is equals to, I'll write this as integral pi by 6 to pi by 3, 4 divided by cos to the power of 4x minus of integral pi by 6 to pi by 3. I can write this as cosecant square x multiplied by 1 divided by cos to the power of 4x dx. Okay. By taking it as a single term, it gets very difficult to solve the integration. That is why the obvious idea is to split it. Okay. So let us not change anything about the first term here, but let's try to concentrate on the second term. As you can see, I wrote it as cosecant square x multiplied by 1 by cos power 4 for obvious reason, because we know how to integrate this one, right? Cosecant square x, and that's why I'm going to take this as function v and this as function u here. Now let me solve the by parts. So capital I is equals to integral pi by 6 to pi by 3, 4 divided by cos power 4x minus of, now this will be u integral v. So what is u integral v here? 1 divided by cos power 4x multiplied by integration of cosecant square. Integration of cosecant square x is simply minus cot x, where limits are from pi by 6 to pi by 3, right? And minus of integration of pi by 6 to pi by 3. Now it should be u dash. So differentiation of 1 by cos power 4x will be minus 4 divided by cos power 5x multiplied by differentiation of cos x is minus sin x and multiplied by integral v. So integration of cosecant x is minus cot x. Okay. And the reason this is advantage to us is, if you expand, let's see the expansion, you'll understand. Pi by 6 to pi by 3, 4 divided by cos power 4 of x dx, and this will be minus of, you can substitute the limits here and you can take minus common, minus of minus plus, remaining part will be cot x divided by cos power 4x, limits are from pi by 6 to pi by 3, and this will be minus of minus plus, and once again minus of minus plus, and one more minus sign is there, which gives you minus of integral minus pi by 6 to pi by 3. And look at this term sin x into cot x here. Sin x into cot x will give you directly cos x, right? And one of the cos x gets cancelled here on the last term. And finally, the leftover part is only 4 divided by cos power 4x dx. I think now you understood what's the reason I have done only the second part solving but not the first part. Because this first term here and the third term here both are same, and the leftover part is only this capital I is equal to cot x divided by cos power 4, where limits are from pi by 6 to pi by 3. Now we know what to do. This is cot 60, right? Cot 60 is 1 by root 3 and whole divided by cos 60 is 1 by 2. So 1 by 2 whole power 4 will be 1 by 16 minus of cot 30 will be root 3 divided by cos 30 will be root 3 divided by 2 whole to the power of 4, which is 9 divided by 16, and then you can solve the remaining part by yourself. Okay, so which will give you what? 16 divided by root 3 minus of, what is this one? This is 16 into root 3 divided by 9. So this is your value of I. Okay. And based on this, I think you got the idea, right? Because if you take it as one single term, you will not be able to solve it directly. So for these kind of questions, you try to think it in this way. Leave the first part and try to solve the second part using by parts, so that the first part which we have not solved, that gets cancelled while solving the by parts of the second part. Okay, so this is one of the important model, and questions like this already appeared in the previous JEE mains also. Okay, let's see the next question. Consider a set A 1, 2, 3, 4, 5, 6, and the number of 1 functions f from A to A, such that f of 1 should be greater than or equal to 3, and f of 3 is less than or equal to 4, and also f of 2 plus f of 3 is equals to 5. Okay, so basically it's a question involving permutations and combinations and also functions. So generally in JEE mains or also JEE advanced, the questions which are involving both PNC and functions are going to be very tricky. Let's try to understand very carefully. Now the main thing we have to concentrate here is the function must be definitely a 1 function here, and it is a function from set A to set A, so which is containing 6 elements: 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Set A to set A. Okay. Now observe carefully all the restrictions that are there here, f of 1, f of 3, f of 2 and 3. Only it is on the elements 1, 3 and 2. Okay. So only on the domain elements 1, 2, 3 we have the restriction. So the remaining elements in the domain don't have any restriction. Okay. That is why let us try to first observe the conditions or number of cases based on f of 2 and f of 3 here, and also f of 1 obviously. So first what I am going to do is I'll try to list out the cases for f of 2 and f of 3, f of 2 and f of 3. Based on this f of 2 and f of 3, I am going to calculate the values of f of 1 here. Okay, so let us do it case by case and very carefully. Now, first thing, f of 2 and f of 3 can be 1 and 4 because 1 plus 4 is equals to 5, because as per the question we have to keep in mind that f of 2 plus f of 3 should be is equals to 5. So if you add both these, you have to get the answer as 5. So one possibility is 1 comma 4 here. And then if f of 2 is 1 and f of 3 is 4, clearly f of 1 can be only 3, 5 and 6. And what's the reason behind that? Because we have one more restriction here. F of 1 should be definitely greater than or equal to 3 only. Okay. And why did we not take 4 here? Because it is a 1 1 function, right? F of 3 is already mapped to 4, which means f of 1 cannot take 4 in this first case. That is the reason f of 1 has only 3 possibilities here. So which makes the first case as 3 cases possible total. Okay, and now let's see the remaining case. Now this is also possible obviously. F of 2 is 4 and f of 3 is 1, and in this case also what happens here, since f of 1 greater than or equal to 3, again f of 1 can be either 3, 5 or 6. So this will also give you exactly 3 cases, right? And then let's take the next possibility. F of 2 can be 2 and f of 3 can be 3, because 2 plus 3 is equals to 5. And if this is the case, what are the possible outputs of f of 1 here? Let's see that f of 1 can be only 4, 5, 6 here, because it cannot take 3, because already 3 is mapped to f of 3 here, right? F of 3 is already 3, so you cannot put f of 1 also is equal to 3, because it is a 1 1 function. So in this case also you get 3 possibilities for f of 2, f of 3 and f of 1 combinedly. And one last possibility is 3 and 2, the reverse case. Even if it is 3 and 2, you get f of 1 as 4 comma 5 comma 6 obviously. And then here also 3 cases you are going to get. So finally, for the combinations of f of 2 and f of 3 and f of 1 combinedly, we get the total number of cases as 3 plus 3 plus 3 plus 3, which is equals to 12. Okay, and this 12 is the number of ways in which only the elements 2, 3, 1 can be mapped here. Okay, so look at this. In the question, we have done the cases only for 2, 3 and 1 in the domain. 2, 3 and 1 in the domain. And then clearly, since it is a 1 1 function, 3 of these elements will be mapped to 3 elements in the output, which means 3 more elements will be remaining in the domain and 3 more elements will be remaining in the codomain. And since it is a 1 1 function, 3 elements mapped to 3 elements, which will give you exactly 3 factorial ways. I hope you are getting this point right. We have already found out the cases of elements 1, 2, 3 in the domain. So for example, this 1, 2, 3 maps to 3 elements in the output, because it is a 1, 1 function. And then after mapping that 1, 2, 3 in the domain, you will be left with 3 elements in the domain 4, 5, 6. And because 3 elements are remaining in the codomain, and these 3 elements must be mapped to those 3 elements such that the entire function becomes a 1, 1 function. So it's like filling 3 places with 3 objects, which will exactly give you 3 factorial ways. So in total, we are going to get 12 cases for 2, 3 and 1 elements in the domain. And for the remaining 3 elements, it is going to be 3 factorial ways. That is 12 times of 6, which is equals to 72. Okay, so this is your answer. So as I told, it's a somewhat tricky question. If you try to properly write down the cases, it is not a difficult one. Just proper idea is required. Okay. So these are the top 10 questions that I observed from the shift 1 of April 5th JEE mains. Okay. So in the next video, I will take the questions from the shift 2 of 5th April. Okay.